We're back with part 2. So we're going to go talk about SRSs and actually how to do SRS. Okay, so what we have here is we have a question that says your school will send a delegation of 35 seniors to a student life convention. 200 girls and 150 boys are eligible to be chosen. So that's your population. Think about it, it's 350 total students. 350 total students. 200 are girls, 150 are boys. So that's my population. If a sample of 20 girls and a separate sample of 15 boys are each randomly selected, it gives each senior the same chance to be chosen to attend the convention. Okay. Is this an SRS? And the definition of SRS is, when you hear an SRS, it should say every group of, and the generic definition is of size N has the same chance of being selected. So in this case, we are selecting 35 people to go because we are 20 and 50. So there's 35 people to go. So my sample size N is 35. Does every group of 35 have the same probability of going, the same chance of going? And if you look at this, when we restrict it to 20 girls and 15 boys, I'm telling you that every group has got to be 20 girls and 15 boys. Every group of size 35 doesn't have the same chance. What I mean is, I can't get a group of 35 girls. I can't get a group of 35 boys. I can't get a group of 34 girls and 1 boy. So what that means is that every group of size 35 does not have the same chance of going. So this is not an SRS because of that. It's not an SRS because not every group in the same size has the same chance of being selected. Okay, now, basically what they say now is they want us to just proceed through with selecting girls. So they want us to go ahead and they want to go ahead and select the first 3 girls, senior girls. So how do we do this? The first thing we need to do is we need to assign numbers. So we have 200 girls in the class, 200 girls in the class. We need to give each one of those girls an individual number. Now here's the thing, we can't label them 1, 2, 3. So we can't do 1, 2, 3, all the way up, ... to 200. We can't do that because these lengths of the numbers are not equal. This is a 1-digit number. This is a 3-digit number. If we were putting names in a hat, that'd be a whole different thing. And I'll kind of summarize something at the end with that. But in this case, what we need to do is give the numbers the same length. So we'd have to make it 001, 002, 003. So that's what we'd need to do. That's the first piece that people usually miss. So what I'm going to say is I'm going to assign the numbers 001 to 200 to the list of senior girls. Each girl gets their own number. Okay. Next, what I'm going to do is I have to decide what's going to happen if I use any unused number. So in this case, the numbers 201 to 000, because those numbers could be drawn, are going to be ignored. The reason they're going to be ignored is because I don't have any girls that fall from 201 to 000. 000 would be like 1,000. I also need to address what I'm going to do with any repeats. So I can't pick the same girl twice. I can't have 20 girls going and pick the same girl's name twice. So what I'm going to do is I'm going to ignore repeats. And typically we are going to ignore repeats. This is called without replacement. We'll learn about this a little bit later, but I just want to kind of pop that concept in your head, without replacement. So what we've done is we've assigned the numbers. We say what we're going to do with anything we're not using. Now, the next thing that we need to do is we need to describe the process. So what I'm going to do is I'm going to select a 3-digit number from the table above, starting at row 108. And I'm going to say if that number is between 001 and 200, that girl associated with the number is in my sample. So in this case, if you look at it, first girl is 609. That's outside the range, not in my sample. 407, not in my sample. 202, not in my sample. 241, not in my sample. 786, not in my sample. 824, not in my sample. 943, not in my sample. What we got? Did I miss a number there? 609, 407. I did. It should be 202 here. 202, not in my sample. 478, not in my sample. 682, not in my sample. 494, not in my sample. We're going to go with 361, not in my sample. 790, not in my sample. 906, not in my sample. 568, not in my sample. 796, not in my sample. 418, not in my sample. 883, not in my sample. What we're going to do is 360, not in my sample. Here we go. 91, girl 91 is in my sample. So what that would be is that girl 91 would be in my sample. So this is not an ideal process, and I'll show you an easier way. And what I would now say is I'm going to stop at 35. I'm sorry, at 20 girls. I'm going to stop at 20 girls because that's how many I want to get. Stop at 20 girls. So now that's a very long process. Let me explain to you the big hat process. Here's the big hat process. I have myself a gigantic baseball cap. There's my gigantic baseball cap. The way I'm going to describe my process is for random sampling, I am going to write all 200 girl names on equal sized individual sheets of paper. Okay, so I'll bring this down. I'm going to put all the names in the hat. I am going to, this is the important part when I do this. I'm going to shake the hat up. And then what I'm going to do is I'm going to select 20 girl names. I call this the big hat process. It's a valid way to do it. Giant box, giant hat, whatever you want to say. But the big thing is you got to shake the hat up. You got to mix the hat up. Because if you don't, when you put those names in, the last names in are on top. They're the most likely ones to be picked. So what we need to do is we need to make sure we shake the hat up. You can either do this, which is, I know, a lot of work, and sometimes this will be in a multiple choice. It has been in free response in the past. I'll go over it a few times in class so we can practice. But if you're ever asked to describe it, this is probably the easiest way to do it. So hopefully that helps. So this is our second video. We'll be moving on to our various sampling methods on day 2. Have a good day.